Okay, we are moving along. Lesson 5. All right, so we're moving a little bit off of constant proportionality. I may get back to that eventually, but for lesson 5, simplifying and evaluating algebraic expressions. Okay, this I think will be new to you. An algebraic expression is an expression that contains one or more variables. Variables are the letters. Okay, they represent something that can change, and that's why they call it a variable. Something that's variable can change. You can simplify algebraic expressions by adding or subtracting like terms, meaning x's belong together with x's, y's belong together with y's, a's belong to a's, and b's belong to b's, and so on. They're very racist in a silly way. You can't mix them up. Like terms contain the same variables raised to the same power, so exponent. So if it's x squared goes with x squared. X squared plus x squared can happen. This would be 2x squared. Okay? Number properties can sometimes help you simplify algebraic expressions. For example, the commutative property states that the order in which two numbers are added or multiplied does not matter. You still commute. You get there. The associative property states that the grouping, associative is always grouping. Associative always has parentheses, right? Grouping numbers being added or multiplied does not matter. And the distributive property is very algebra. Okay? The distributive property can help you expand algebraic expressions. It states that multiplying a factor by a sum is the same as multiplying that factor by each addend in the sum and then adding the products. Oh my God, lots of words. Don't worry about that. This property applies to subtraction. Also applies to. You'll get this. You could also evaluate algebraic expressions. Just substitute the given values for the variable and simplify using the order of operations. Okay, so let's watch. Expand this expression. This means 5 is being distributed to each piece. This 5. It's 5 times this, then plus 14b. So use the distributive property to expand the first part. So it's 5 times 6a, then minus 5 times 3b, and then eventually we're going to go plus 14b. So that's just the first part. 5 times 6a is 30a. And then 5 times negative 3 is negative 15b. So, when you see the original, if I distribute the 5 to each one, meaning multiply, I get 30a minus 15b plus 14b. Okay? Now, when I look at this, I'm going to write it over here. 30a minus 15b plus 14b. When I look at this, I have 3 terms. I have 3 parts to it. I have an a part, and I actually have 2 b parts. The b parts can be combined. A negative 15b and a positive 14b really means when you put those together, you end up with negative 1b. So 30a stays 30a. There's nobody else to combine with. There's no other a terms. But the b terms can come together. And when I put these two together, I get negative 1b. So my answer to simplifying this whole problem comes out to be that. Okay? Which is down here. Okay? Does that make sense? Addition is commutative, is subtraction also commutative? Justify your answer. Okay. Not always with the positive and negatives. You have to be careful. Be careful on how things are written, how the problem is written. A negative sign looks like a minus sign. But now you must think, looks minus, but we must think negative. Okay. Think negative. All right, so let's go to the next page. This you might need more guidance with, which is fine. Stick with me, you will get it. All right, so if I look at this, I scan across 5x plus 8y plus 7x plus a negative 3y. Use the commutative property to reorder them. In other words, group them together. Okay? So I want to put my x terms together and my y terms in one section. So the way this is written here, when you reorder the addends, put like terms next to each other. So 5x needs to be beside 7x. So the 5x and the 7x need to stick together, and the 8y and the negative 3y stick together. Use the associative property to group the like terms. So 5x plus 7x, parentheses, plus 8y and 8y plus a negative 3y. Put them together. Okay? So let's combine them. So 5x and 7x makes 12x, right? And 8y and a negative 3y. 8y and a negative 3y. That means 8 take away 3 leaves you 5y. So plus 5y. The simplified form of this is equals 12x plus 5y. My x terms are together and my y terms are together. Okay? Next part says, evaluate the expression below when m is negative 6 and n equals 3. So m is actually negative 6. Oh boy. And n is equal to 3. So in this problem, m squared minus 8 times n. So that means negative 6 squared minus 8 times 3. Right? First evaluate the exponent. So a negative 6 times negative 6, that's negative 6 times negative 6 is negative 6 squared. Negative times negative makes positive, 36. And then this is minus 8 times 3. 8 times 3. Okay? So 36 minus 8 times 3. So the next line is going to be 36 minus 8 times 3 is 24. So 36 take away 24 equals 12. The value of this expression comes out to be 12. So this is a lot of order of operations. There's a lot of positive and negatives that I am hoping Mr. Chen got to that. Well, I'm going to move on. Hoping he did, and you can follow along my steps. Okay. Next, page 22. What is an algebraic expression? Right here, an expression that contains one or more variables. It contains one or more variables. Okay, it's not an equation, right? An example could be 2x plus 3y. There's an algebraic expression. Which number property shows here and explain? So we just move the grouping symbols, right? The associative, right? So this is associative. Okay, because we have grouping symbols and it did not change the operation. All right, let's go right to the problems. Simplify each expression. Same family, 5x plus 6x makes 11x. 9a plus 4a, but then minus 3. Well, I can only combine these two. 9a plus 4a, 9 and 4 makes 13a, so 13a, and then minus 3. That's all you do. 3, there's nothing else to combine with the 3. We got to keep it like that. Next one. 7p plus 6 minus 5. 7p is the only one with the p, so I'm going to leave that as 7p. And 6 and 5. 6 minus 5. 6 minus 5 means plus 1. 12z minus 3z. 12 take away 3z. 12 take away 3. 9z. Okay, this is distribute. Nice, here we go. 3 times 4 and then 3 times 1. Because this is saying 3 groups of them. So if you rewrote them 3 times, that's what we're doing here. So 3 times 4x would make 12x. And then 3 times 1 makes plus 3. So it's 12x plus 3. Division. 15x divided by 3 minus 5x. Well, 15x divided by 3 really makes 5x. But 5x minus 5x makes, these two would cancel each other and make 0. So that answer is 0. Evaluate each expression. If k is negative 3, so this would be 5 times negative 3. And 5 times negative 3 makes negative 15. Number 11. 10 minus 3 times 2. 10 minus 6. 3 times 2 is 6, so 10 minus 6 is 4. Put a 4 in here. 6 times 4 minus 2. 6 times 4 is 24 minus 2. The answer is 22. M squared plus 2 if m is negative 3. So this means negative 3 squared, then plus 2. Negative 3 times negative 3 plus 2. 3 times 3, that makes positive 9. Negative times negative makes positive, plus 2 makes 11. The expression L equals 1 plus 2w represents the length of a rectangle L to its width. If the width of the rectangle is 3 units, w is 3, what is the length? Okay, so L equals 1 plus 2w. And they're telling you w is 3. I'm going to put 3 in there. So the length equals 1 plus 2 times 3. 1 plus 6 makes 7. So the n equals 7. Make sense? Okay. Page 23. How about give it a shot here? Okay, so ignore my writing at top. Do these, try these, and this, and then I will put the answers up. So try this, and then we will whip through it together. Okay?